Welcome, my name is Johannes Stiehler, Chief Technology Officer of ayfie, as mentioned before. And I'm here to talk actually not about our product, but my intent is to give you a little bit of background information on AI and a little bit of a framework to help you understand what's going on in that space today, even outside of legal, and how you can basically understand what you see in the press versus what you see in reality, which often differs wildly. If you look at press articles about AI, they're mostly driven by innovations in deep learning. Most of the articles about that, really. And they are always headlined to the effect of researchers found an impressive way to do something. They are very rarely headlined, somebody found a productized way to do something useful. It's mostly something impressive, it's a very isolated use case, and it sounds grand. For instance, AI can now tell benign moles for melanoma better than human doctors could. You will not see a tool actually doing that until maybe 5 years in, or maybe never, because there's also articles where it says AI is better than human radiologists, and then you turn around and you see in reality it's actually a 50% guessing chance, and you really don't want to expose yourself to that if you have a medical problem. So the press articles and the reality differ widely, and the question is why that is. And the question is also how you can then separate the hype that I believe we all agree we're currently going through in terms of AI and deep learning from what is actually possible and what will actually help you in your day-to-day work. Since there is so much hype going on around it, usually this leads to a very strange way of people forming opinions, because there's not much information to go on, but there's a lot of opinion and a lot of different influences. So generally, if you talk to people about AI, they tend to have one of three possible opinions about AI. The first one that you can hear a lot is the pessimistic opinion, which basically says AI is going to kill us by 2025. Well, then we don't have any problem. We don't even need to learn about it. It's going to end soon anyway. The slightly less horrible version of that is AI is going to get rid of all jobs by 2025, which is also very pessimistic, but at least we'll survive and probably served by robots. The very optimistic view of AI and the general advancement in this technology is that it will solve almost all menial problems we have in our everyday lives. Self-driving cars fall under that umbrella. So AI will help us do what we like and not do what we don't like. It will order food for us. It will get appointments with the doctor for us. It will drive our cars so that we can actually read a newspaper while we go to work. And it will offload of whatever is tedious and repetitive. And that is also sort of the promise of a lot of the tools that apply to specific problems as opposed to general problems. And self-driving cars are possibly the best example of that. And then there's what I would call the realistic view, which is basically, okay, I know this vacuum robot works. I know it's actually cleaning up my living room okay-ish. Very bad when it actually gets in contact with the dog. And I do know that I have to clean up after it a little bit. And I also do know that it might fall down the stairs eventually. So that is what I call the realistic view of AI. And that's mostly the view of people who actually work with AI at some point. And who are not only reading about Google building an autonomous car or whatever the next technology hype is, and who not only read about robots taking over the world, but who actually work with this technology. So they understand there's some realistic outcome to be expected from this technology. They also understand there are limits to what it can do, and depending not on how good or bad it is, but what exactly those limits are, it is possible to use it in a certain context or not. So the most boring question of all is, of course, what is AI? We've used that term probably 100 times by now without explaining it. And I'm not going to bore you with the Merriam-Webster's definition simply because of the fact that there is none. There's no generally agreed upon definition of AI. But I can tell you what the range of software is that we need to look at in order to understand where the AI tools fall. Very basic piece of software, Microsoft Word. Would anybody consider that AI? Didn't think so. How about Clippy? Anybody remember Clippy? I see a lot of warm and affectionate feelings. So Clippy, at the point when it was introduced, would actually have been considered AI to some extent, especially if you define AI as a knowing item. But it did exhibit some form of intelligence, tried to understand what you were doing, it tried to help you. Most of the time it was just really awful, but it had some level of, yeah, not intelligence, but helpfulness too. Then on the other end of that spectrum, you have things that are certainly AI. Nobody would doubt it. For instance, AlphaGo winning against the human master in the game of Go. Nobody would doubt this is AI. But also nobody would doubt that it's a very specific AI. There's no general intelligence behind it. It's just a way of automatically solving a very specific problem. So somewhere in that range, we have all these different tools that you work with today. You have digital assistants. They're certainly closer to work than to AlphaGo at this point, I believe. In terms of power, you have assisted writing tools that will help you draft a contract, for instance. You have all these different analysis tools that are out there. They fall in that range somewhere, and they are more or less AI. But the definition of what is actually AI is constantly changing, and we have to be aware of that. Because what they all have in common is they aim at being comparable to humans in terms of their output. They don't use the same method as human. No AI does that. And there's a good reason for that. We also don't build airplanes that flap their wings. It's usually not the most efficient way to imitate something existing to solve a problem. And what they all also have in common, they memorize and compute quicker than any human ever could. So speed is probably never going to be a problem with AI. AI will always be quicker at figuring something out, but that doesn't mean it doesn't make mistakes. It might just make those mistakes quicker. And a certain element of magic also always has to be present for us to consider something AI. It has to be amazing that the software can actually solve that problem. Otherwise, in our minds, we don't really consider it AI, which is why the bar is kind of raising all the time. So what you would have considered AI 10 years ago is sort of, yeah, that's an everyday tool today. In 1966, somebody wrote a computer program called Eliza, which you could consider the first conversational AI. It basically just, I don't know if anybody remembers that or read about it at some point, so I don't want to bore you. But it basically just, if you asked it a question, it would repeat the question back, paraphrased with an answer. So if you said, I'm worried about my job, it would say, oh, why are you worried about your job? Or tell me more about your job. And if it didn't understand you, it would say, well, that's interesting, tell me more about that. And it was meant as an experiment, but it was branded as a psychotherapist, because apparently researchers back then thought that psychotherapists they can get away with not knowing about context and not being very helpful in their answers. So they built that program to be that. And it was AI back then. Today we would say, okay, it's a simple script. You would never say AI to that. But it's amazing how some of our digital assistants are still pretty close to that original model. So there's some magic in it. None of the AIs we have, and none of the AIs we will have anytime soon, are thinking creatively. They are all just applying some preconceived mathematical solution to a known problem, which is what is generally called narrow AI. If you look at the space of AI solutions out there, and I'm not going to go into details, but it is important to know this a little bit so you understand what the effort is that is involved. The most basic way of solving a problem with a computer is a mathematical model. So you have like a formula or some way of computation that solves a particular problem. If you have the right data, you can apply the model, and it will come back with an answer. There will be always the same answer. There's no element of randomness to it, and it will be based on what you feed it. It won't be based on what you train it to do or anything. You don't have to do anything to make it work. It will just apply a mathematical model. And if you look at especially discovery, a lot of e-discovery tools still use LSI, which is an algorithm from the 90s. So a little age at this point. But the good thing about LSI is you don't need to train it. It's going to do a computation that you could do with a paper and pencil. If you are good in math, it will take you a while, but you can still do it. And it will apply the computation to whatever text you throw at it, and the output will always be predictable. Doesn't mean it's going to be great, it's just predictable. So same text, same outcome. And you basically don't have to do anything except feeding it the text. So the effort you have to invest to get that done. It's relatively low. Magic factor for anybody who's worked with LSI-based tools also relatively low. Close to none, actually. Then you have rules-based systems. They have always existed because that's kind of how you think about things if you're a human. If you think about the cat example before, it's basically a rule-based example to say we describe a cat. And you can set up 1,000 rules describing a cat, and eventually you might actually get a decent precision, but it's probably the right tool to solve that. There are very powerful rule-based tools out there. Good thing about rules is you can let the vendor write them. They usually fit several different problem domains, and they're very wide box. So if something goes wrong, you can go back to the rules and say, okay, which rules cause this exactly, and remove it. If you look in the space of self-driving cars, again, a lot of the cars are actually rule-based, very advanced, very elaborate, very crazy, but still rule-based. There are some. NVIDIA built one that are pure machine learning based, and the problem with those is that NVIDIA said, okay, it's going great and it's doing a good job, it actually navigated the city quite nicely, but you have no idea why. So at the next junction, it might run somebody over because we don't know why it's doing what it's doing. So that's a little bit of the problem with more advanced solutions, is that as opposed to a set of rules, it's very hard to look under the hood and see why things are going on. Then you have supervised machine learning, which is I can also call that classic machine learning. The old way of doing machine learning, which basically means you feed in an algorithm, a specific algorithm, examples of what you want to find out, and the algorithm will learn from that. That would be showing an algorithm 100 articles from Wikipedia about animals that are good as pets. So you show that you feed it articles about cats, and dogs, and certain birds, certain fish, and so on and so forth. And after 100 examples, the algorithm might have picked up on the concept of a pet. So if now you feed it a document where you don't know if it's a pet or not a pet, it will give you an answer with a reasonable accuracy. So in 90% of the cases, you might be right about the petness of the animal. And then you have deep learning, and it's important to take this away. Deep learning is a completely different beast. It's still machine learning, but it's using different approaches. And deep learning is what's driving all this press these days. So whatever you read in the press about impressive new advances in medicine, or whatever Google does in terms of image recognition, that's usually deep learning. Deep learning has enabled us to solve problems that we could not solve before. For instance, recognize what is on a picture. But deep learning also has a couple of shortcomings that make it very non-feasible for business-like applications. I'll talk about that in a second. All of these are AI, can be used to create AI. All of these are used to create AI. As I said, deep learning has the most trace factor these days, but it also has the worst predictions. So if you think about what Elon Musk said about self-driving cars, I think he predicted 2 years ago that they would be autonomous in 2 years. Unfortunately, at this point they are not. There's still a lot of work to be done there. So now it's predicting another 2 years, and in 3 years it will actually be better than a human. I highly doubt that, but that is a typical deep learning prediction. So you solve a particular facet of a problem and then you generalize and say, okay, we got that covered. Just another 2 years. Normally it's more like 4, 6, 20. So there's a lot of unrealistic expectations surrounding that. What is the main difference between machine learning and deep learning from your perspective, which is the end user of the product? In order to teach a classic machine learning algorithm to separate a pet from non-pet, you could feed it 100 articles and it would be doing a very good job. It would be able to understand the petness of an article with a pretty nice accuracy. If you use a deep learning algorithm to tell sheep from non-sheep in an image, then you'll have to feed it 100,000 examples, which makes it a little bit harder to handle in most cases, and which also makes it very unusable for problems where you just don't have that kind of data. So we're talking about 100 images of something that you know to be a sheep before the algorithm will be able to tell you sheep from non-sheep. It won't be able to tell you what the non-sheep is. It could be a cat or I don't know, a piece of carpet. But it will be able to tell you, so this is a sheep with a very high reliability. And that is deep learning for you. A lot of data, relatively complex learning algorithm, and then you get very good outcome and problems where you couldn't have that outcome before. The good thing about deep learning is also you can almost always make it better by feeding it even more good examples, provided that you have them. And that is exactly the issue that we're facing with deep learning in terms of B2B software. Most people don't have 100,000 compliance clauses to feed into a system, so deep learning is not the perfect way to train them. Even with classic machine learning, there are training phases. I know that software that comes pre-trained and so on and so forth, but if you want to solve problems that are very specific to your workflow and to your data, you'll have to have that training phase that you, as the user, will have to invest some time in, which means expert time. Not janitor time, but actual experts who know what they're doing. So what does this mean for AI software? Generally, because of the hype, because of the press, because of what you read, because of what you understand or see from marketing materials, effort and duration of the training and the tuning of the system is often underestimated. And what is even more underestimated is requirements towards the data. So if you're trying to solve a specific problem, like analyzing mortgage documents for consistency, so you want to find out if the mortgage package in the homeowner's insurance and if the mortgage application and some other documents has the same property address, you can of course use an AI solution to do that. But what is often underestimated is that if your scans are bad, you're done. You don't even have to start. So if your mortgage document is more than 10 years old, it's very unlikely that the resolution of the scan is not going to be high, which again makes it very likely that the AI solution is going to say, okay, I can't recognize anything from this document, and move along. So the quality of the data that you have to feed it in order to make it work is also often underestimated. And that pertains, it's true specifically for scans. I'm repeating that because we face that so often. Because many documents are still on paper or have been on paper are now scanned. So that's a completely different game than trying to analyze something that has been electronic to begin with. AI can process huge volumes of data. It's great at that. It can do that very quickly. But it also has the potential for huge mistakes because of that. So you have to figure out how to deal with those if they happen. And that's like my golf teacher always told me, very far out of bounds is still out of bounds. So getting there quicker will not help you. Right? So you have to understand that there is a danger of AI software making mistakes. And if it's making mistakes quicker than anybody else, that also might have a bigger impact on what you're trying to do. So how to go about that? How to understand what AI tool to use and how to understand if it actually provides a positive ROI. The first thing I would recommend, and I'm saying that as a technology vendor, so it's probably true because it goes against what I'm actually interested in. You should start with your workflows. You should not start with the tool. I see that very often in trade shows that technology vendors, and we're probably not an exception, but I'm not going to say it, go to you and say, okay, we have this tool, it does this specific thing, so that must be your problem. It's usually not like that. Usually you have a problem that is related to how you work with certain types of data, related to your workflow, and you know what the problem is. So the first step would be, what is the specific workflow that you're trying to fix, that you're trying to make quicker, more precise, kind of work together with a tool such as Luminance and a human expert to make this particular workflow better in the way that you want it to be better. That can be accuracy, it can be speed, it can be whatever you think. Then define the expectations. What should the algorithm provide you with? And that is a very important step that is often forgotten. An algorithm that will find a compliance clause with 80% recall, which means 80% of the time that it's in the document it will actually pick it up, is great. It's speeding you up at review. It also means that you will not even look at 20% of the documents that actually do contain a compliance clause. That might not be a problem, depending on what you're trying to solve in terms of use cases. But then again, it might be. So you have to understand what expectations to have in terms of quality towards this algorithm. Should it return all the documents that potentially contain compliance clauses, generating a lot of additional review effort? Should it be rather on the precise side, so when it returns the document, it's certain that there's a compliance clause in it, because that's what I'm trying to solve. That there's expectations around that, you need to be aware of that. If the algorithm returns 80% of the clauses, or 90%, or even 95%, that still means you're missing 20, 10, or 5% of the clauses. And if that's okay, that's great. If it's not, you have to understand how to work around that. Then you have to see if an AI solution is out there that can solve that problem and that can fulfill the expectations. More often than not, you only look for a solution that's solving the problem, and you forget about the expectations, and that kind of comes later, and then everything gets very confusing. Identify the limits and requirements for that software. So what do I have in terms of upfront training? Do I have certain requirements regarding the cleanness of the data? What are the limits of the solution? What are the limits in terms of accuracy, throughput, and so on and so forth? And then deal with the gaps. And that is when this human-AI interaction comes into play. So where the software has gaps, you have to throw a human in. Usually somebody who knows what they're doing, and the software has to support that. So if the software does not return 20% of the clauses, ideally it will give you a way to deal with that by having an additional layer of review using human agents, human people, whatever you want to call them. And you have to take care of the monitoring part. That's the out of bounds part. So if a software runs for a long time, there's generally a lot of excitement about introducing such a tool. So everybody's, from senior management all to the lowest ranks, everybody's super excited. We're getting a great tool, everything's going to be great and quicker and so on. Then you work on introducing it 4 or 5 months, and that's not unrealistic. It might even be much longer than that. And then you forget about it because it runs. But all tools need monitoring from a quality perspective. If your data changes, the outcome of the tool might change. It might need adjusting, it might need replacing, even if the landscape changes completely. It might need updating in terms of what are new regulations that we want to take care of with this tool. So there needs to be an element of monitoring that tells you when things veer off course, even when you've used the tool for 2 or 3 years. Software will always make mistakes, and it won't do you the favor of making those mistakes in the first 5 months when you're watching it very closely. It will definitely make those later too. And then all of that has to go into the ROI computation because that's all effort, right? The upfront training, the installing, the monitoring, the dealing with the gaps, even understanding the limits and requirements, all that is an investment. And if you forget 3 of those, you will never understand if the license cost that the tool will actually charge you, the tool provider will charge you, is offset by the benefit that you get from it. So bringing that back to a specific use case, if you think about GDPR, since we're talking about that a lot, there are AI tools out there that will help you identify PII in documents, no question. They will do a fairly good job, maybe getting 90% of the PII, maybe even getting more. They will be able to give you reports, they will be able to give you very precise search and so on and so forth. But they will still miss things. So you will have to design your workflows around that. You will have to define your workflows in such a way that you deal with the stuff that they're not picking up. But then again, AI is great for this problem because it enables you to understand your PIIs. Manually, that will never be possible, especially with regulation like GDPR, where you actually have to deal with historical data too. How would you sift through millions of documents that potentially contain somebody's name somewhere? You could, so AI is about the only solution you can use for that, but you have to understand the limits and you have to find out how to deal with them. On the other hand, if the first AI comes along that is actually able to check a contract for GDPR compliance, I'll be starting to believe in magic too, because there's so many implications that I don't see any software tool solving that anytime soon. So there you have the range. Analyzing, understanding, plowing through huge volumes of data, that's great, that's AI. Thinking creatively, applying very complex expert knowledge that requires context, which means prior knowledge or additional knowledge about something, you can pretty much forget about it for the foreseeable future. If you want to discuss this some more, if you want to disagree with me, people tend to do that, come visit us at Table 9, where we'll be happy to follow up on this conversation. Thank you.